Let's start this. A long glass tube is almost completely immersed in a glass tank of water. A tuning fork is struck and held just above the open end of the tube and is slowly raised. This is a very important point. Slowly raised. Slowly raised means that they are moving the tuning fork upward. A louder sound is first heard when the height of the end of the tube above the water is 18.8. Now, the louder sound, louder means antinode. Sorry. Antinode. What is the frequency of the sound produced by the tuning fork? So, a louder sound is first heard when the height is above height h of the tube of water is 18.8. So this is the first antinode. The second antinode is at 56.4.
So antinode to antinode, it's lambda by 4.
You're right. It is antinode to antinode. So if I say here that first antinode is at 18.8 and the second antinode is at 56.4. So I can say this difference is lambda by 2.
It is coming 75.2 centimeters, the wavelength.
17 point.
75.2. And node to node is also lambda by 2.
It's always there, na? Node to node or antinode to antinode.
It is coming like a very high answer.
Acha.
No, I think
Uh,
I did something wrong. It is 438, so 440 almost.
So it means the answer is B.
I took the height as millimeters first. That is why it was coming higher.
Acha, that's fine. Now we move to light of wavelength 567 nanometer is incident normally on a diffraction grating. The grating has 400 lines per millimeter. So this is lambda. This is n per millimeter. What is the angle between the second order maxima and the third order maxima? This is the way to calculate D.
It is 2.5 into 10 minus 6. So why did we take it as 400,000? We could have taken it as 4 into 400 into 10 minus 3 as well.
No, it can't be minus 3. It should be because I'm not converting millimeter to meter. I'm using a logic. If there are 400 lines in 1 millimeter, how many lines would be in 1 meter? It's not a unit conversion, it's a ratio.
Okay, I got it. So 1000 into 400 they will be.
Ah. So first we need the two angles. Calculated should be in degree mode.
The first is coming as 26.97. 26.97 degrees.
(26.97 degree).
Yes.
What about theta 2?
Now we will take the theta 2 as 3 because n lambda d is equal to d sine theta and n will first.
You're right. You're right. I didn't check it, and I by mistake I took 2. You're right. It's not 2. It should be 3 because it's a third order.
It is coming as 42.87. So the difference is 15.9.
It means the answer is C.
There is so much working just for 1 mark in this.
This is the place. This is actually something which I always tell my students when we are in a regular class, that actually paper 1 is more challenging than paper 2. But the good point is there. That the threshold is very low. It's a very low threshold paper, 27, 26, sometimes it's even 25. So many people get disappointed that this paper is so hard, every question is so difficult. But remember, if paper is difficult, that's right, but it's a very low threshold paper. So you have a good range for even getting an A. It's quite a good range. A double slit experiment demonstrates interference between two coherent sources of light waves. In the diagram, the curved lines represent wavefronts. At which point does complete destructive interference a minimum occurs. Now remember this rule that the continuous lines, when you draw a continuous line like this, it shows crest, and when you have to show trough, you have to show it by dotted line. So it means there are back-to-back trough and crest. So you can see here C and D. Now what you can do here, you can carefully see that if I say trough plus trough or crest plus crest, then it is constructive interference. Trough plus crest So this is the rule to remember. Now you can tell me that where should I mark which points A, B, C, and D. If we look at A is irrelevant because there is no interference at A. There is no interference at A. So this is wrong. B, you can see B is actually both are crest. Both are crest, so B is also wrong. Now the game comes for C and D. Distance is very less, but remember there is a dotted line issue to remember. If I try to, yes, now I think I can draw, but so less space. Now you can see where you can find trough plus crest.
In C.
Yes. An electromagnetic wave is incident normally on a diffraction grating. A second order maximum is produced. At an angle of 30 to a normal to the grating. The grating has 500 lines per centimeter. What is the wavelength?
So it will be 5,000 into 100. The D. It is coming as 2 into 10 power minus 6, the D. Not the lambda, the
2 into 10 power minus 6 or
yes,
6.
2 into
2
10 power minus 6. The distance.
I got it. The D. D is the slit separation.
The wavelength is 5 into 10 power minus 7.
Wavelength is how much?
5 into 10 power minus 7. The B answer then.
Light of wavelength 720 from a laser X is incident normally on a diffraction grating and a diffraction pattern is observed. Light from a laser Y is also incident normally on the same grating. The third order maximum due to laser Y is seen at the same place as the second order maximum due to laser X. What is the wavelength of the light from laser Y? It's a bit tricky question. Later, light of wavelength 720 from laser X. So there are two sources. So it means third order n is equal to 2 and n is equal to 3. They are saying same. Now, same place means same angle. Otherwise, they won't meet at a common point. So that it means theta is the same. So let's say devise the ratio formula here as our practice. The third order maximum is seen as a second order of x. So I put 2 here and I put 720 here.
It is coming as 480 nanometers.
480.
Yes.
An outdoor concert has two large speakers beside the stage for broadcasting music. In order to test the speaker, they are made to emit sound of the same wavelength and the same amplitude. The curved lines in the diagram represent wavefronts. Where is the loudest sound heard? Loudest means
The same crest to crest or trough to trough we have to see.
loudest means again remember that they have not shown dotted lines. So if you suppose want to show like for example, this is the crest.
So is it D? Because there are two troughs meeting. Two
D,
crests.
two crests are meeting, right? Perfect. In an experiment to demonstrate a stationary wave, two microwave transmitters emitting waves of wavelength 4 are set facing each other as shown. So they are facing each other. There is a detector. The detector is moved along a straight line between the transmitter. It detects positions of maximum, which means antinode, and minimum node. The detector is a distance d from the left-hand transmitter. Assume that both transmitters are at antinodes of the stationary waves. Acha, both transmitters are at antinodes of the stationary wave. He has given us lambda as 4. So it's not easy to draw the hole, and even it doesn't look to be needed. But now he says that from the left-hand transmitter, it is obvious that the starting point is empty node. And we know that empty node to empty node, it is lambda by 2. Now we have translated the data, and we have I think we have to do it by the trial and error, the elimination method, because it's lambda by 2. So lambda is 4. Lambda by 2, it means it's 4 by 2, and it will be 2 centimeter. I think we have to remember that the just waiting for it to be loaded.